Okay, happy Friday morning, and thank you for joining us for this optional live online session. As always, I wanted to provide a few updates, a little bit of feedback about the last week, and have a look of the kind of what's going on this week, including a nutshell review of the most important highlights of this week's learning chapter. So building from that, like I've mentioned before, um, each week my goal is to provide a summarized lecture version, but please do remember that these are only the highlights. The full lecture material, full learning material is available on your Canvas course, especially through those pre-recorded lecture videos, but I also encourage you to use the homework assignments as a learning opportunity. You have a very nice online textbook as well that ties in very nicely with those learning activities. So here I have a little bit of a plan for what I wanted to cover today, and we'll work based on that. But as always, there's a little bit of room for flexibility. I'll try to highlight very similar things on both meetings during the week, but it is likely that occasionally there's certain things that come up in one meeting and different things in another meeting. So as always, I want to make sure that everyone's doing well on the course, things are moving along nicely. Since we do not have as many in person or even at the same time interactive spaces, since this is an asynchronous course, what I want to do is to encourage you to use that discussion forums that we have for each week as a place to interact. You're always more than welcome to individually contact me, and I'm also super happy to make times outside and including my online office hours and these live online sessions to find the day and find the time that works for everyone, and use that as a chance for us to address if you have any questions, anything that I can assist with. Like I said, I've kind of toyed around with few versions. Finding the optimal time for everyone is always challenging. I am realizing that many of you have other commitments and have other things that you're tied into. That applies also to me with my heavy teaching load and other commitments. So weekends are a little bit more challenging for me, but I am currently exploring an alternative time and day to try if that would be more successful for finding more opportunities for us to get together in this virtual space. So keep an eye on that. I'll see what can be done. I'm also a little bit mindful that I don't want our our meeting for live online sessions to be so late in the week that it doesn't serve the purpose of providing an opportunity to address any questions or any concerns that you might have. Either way, as always, I am recording these sessions, so hopefully that at least is helpful for anyone who can't join in synchronous format to these sessions. I wanted to start before we look more into the weekly homework that we have today by actually jumping and having a look of what we learned from last week and what kind of themes came up from last week's work. So let me again share my screen in a different format. And let's get that up. I think you should be at the moment seeing my screen on this course as if I was a student. So hopefully that's a little more familiar view. My own view looks a little different because I do have a bunch of other stuff that I do at the back end. But this should be fairly similar to what you are used to seeing. And I've scrolled down to the last week's learning module, which was the integumentary system. And one of the assignments we completed there was the food for thought, goosebumps, kind of a short essay type of a question. And first of all, I want to thank you all for a very, very good job on those. I can tell the effort that has gone into those. So that's great and I appreciate it. You'll notice that with the food for thoughts assignments, I usually try to provide also a little bit of lecture material that goes along with that might help you with how to tackle these questions. So last week I provided some videos and articles that might get you started, but there's a room for you on these questions to do a little bit more independent research, find what stands out for you from those activities. They're usually either a more of a curiosity based or more of a application based questions. And a couple of pointers that I wanted to share with the entire class. I provided everyone individual feedback. I provided everyone with their unique comments to your responses is how I would approach these questions. And what I provided for you on the actual activity is the grading rubric that I use when I evaluate your work on that those written answers. So that really should be the guidance for you in terms of what things to highlight, what to talk about, and it talks through the different areas that I'm looking and also kind of examples of what would be a perfect answer, what would be a totally insufficient answer, and what would fall somewhere in between. Obviously, there's always a little bit of room for other aspects that don't fall into these strict criteria that we have in a grading rubric, and I always take that into account when I finalize the grade for the assignment. But this is the backbone that I use when I start uh, kind of evaluating the work that has been sent in, and then from that I take that further and adjust to whatever direction. Things like using references, providing references at the end of your assignment. Those might be helpful, those might be beneficial in terms of impacting the grade positively as well. But I wanted to make sure that I show this rubric as a tool that I, at least as a student, would probably lean on to as I tackle these questions. And again, I'm going to jump out of this screen and try to share another screen, which kind of now we've had a chance to look at our last week's homework. So why don't we look at the homework for this week? And this week I have very familiar structure to what you've gotten used to on this course. So this week's chapter, I'm asking you to look at the chapter 7 quiz, and I'm asking you to look at the chapter 7 practice anatomy. And let me just highlight that those are due at the end of the week. So 1 minute before midnight on Sunday is when these assignments close, and these points add up towards your final grade. So it's worthwhile to collect those. So that's all you have to do for this week, but I did want to mention kind of briefly, because I know that I have some students who are already looking to the next week and starting to think about that. And next week is our first week when we are taking our first set of tests together. And these tests will cover chapters 1, 6, and 7. So what you'll notice is that I will not be covering the chapters in the test that you have already been examined in your prerequisite courses. So you've been already tested for those basic concepts of biology that we revised during weeks 2 and 3, I believe. But all of the new material is being tested. And the format of the tests, I will share more detail about those in a greater detail at the beginning of the next week. But the format is very much of us following what you've seen on the quizzes, what you've seen on the practice anatomy. These are, though, taken fully on Canvas. So you will have an exam that covers more of the lecture material, and you will have a practical which covers more of the kind of identifying structures, looking at pictures, that sort of aspects. Because these assignments, these tests are worth of so many points, I really encourage my students to make sure that you give yourself time to prepare on those and you give yourself time to take those. Like I said, I'll provide all the details when it comes to the format when it comes to how to take it, but this is an asynchronous course, and you do have a choice where and when to take it. They are taken independently on your own time through the Canvas. And like I said, I'll share more details about the practicalities, more details of what you should bear in mind, but hopefully that puts your mind at ease for now until we reach next week when this is our focus. I wanted to move on to talk quickly through some of the highlights from this week's learning material. So this week we started talking about skeletal system, especially focusing on the bone tissue. And before we really dive into the actual bones and skeletal material, I wanted to kind of put everything in a perspective of thinking what happens throughout the life cycle. And we're starting from the very beginning. So early on in your development, the human skeleton is actually made of just cartilage. And that cartilage gets then replaced, or it gets turned into bone through a process known as ossification. So this is an important part of the development, and you'll see that during earlier parts of the life, not all bones are fully ossified just yet. So we'll see that portions of the bones are ossified, but especially the bone endings typically remain non-ossified. We do have cartilage on those. You can see some nice, I have an x-ray picture there where you see the bone standing out nicely. You'll notice that it's not fully developed. The bone ends are still very much developing. There are going to be some parts of the body that remain non-ossified even later in life. These are areas that require flexibility. So we'll see certain structures in the joints, for example, remaining cartilaginous. If we talk about the cartilages, there's really three main cartilage types that we should pay attention to. So let's review those quickly as they came up in our learning material. So the first cartilage type that I wanted to talk about is going to be our hyaline cartilage. Hyaline cartilage is the most common cartilage type. It contains collagen fibers and only collagen fibers. These make these cartilages great for support, but also great for flexibility and resilience. And some of the places where we might see hyaline cartilage include most joints that we have, also the costal cartilages, so where the ribs join to the sternum, to the chest bone. That's another common place where we see hyaline cartilage. We'll see hyaline cartilage in our respiratory system. For example, your trachea has cartilage rings that keep it nice and open at all times. So those would be made of hyaline cartilage. We also see that the cartilages that form so-called voice box are made of hyaline cartilage. And one more part where I think that sometimes students are surprised to see hyaline cartilage is the nose tip. So remember, nose is largely cartilage, only the bridge of the nose is actual bone. So that as well would be made of hyaline cartilage. The second cartilage type that I wanted to introduce to us is our elastic cartilage. And there's less structures where we see elastic cartilage. This type of cartilage is very similar to hyaline cartilage, but this time we're seeing that it contains elastic fibers. And elastic cartilage is found in two main parts of the body. We're finding elastic cartilage forming the external ear that we have. And in addition to the flap-like structure at the level of the voice box or those structures where we're seeing epiglottis, this flap-like structure made of elastic cartilage. And finally, let's look at fibrocartilage. Fibrocartilage differs from the previous cartilages in a sense that we find a lot of thick collagen fibers in these. This gives this type of cartilage a very great tensile strength. Some places where we might see fibrocartilage, we see the menisci of the knee Joints, for example, being made of fiber cartilage. Other good common part where we'll see several times this repeated is in our vertebral column, in those discs between the vertebral bones. So those intervertebral discs are made of fiber cartilage. And finally, I wanted to mention the pubic symphysis, which is also made of fiber cartilage. So few different types of cartilages and few different locations where they might be found. So I hope that that's helpful for you as you're trying to kind of extract what are the most important things to take away from the learning material as it comes to the cartilages. Then I wanted to talk about the bones in general, about the bone tissue. So we see that bones serve many different purposes. A skeletal system serves many different purposes in our body. And one of the purposes that we're going to see is that a skeletal system really gives us the scaffolding for the rest of the body. So that's the support where all other structures are attached. If we didn't have a skeletal system, we really would be this wobbly blob on the floor, and we would not be able to do a lot of functions that we want to do. So skeletal system is really important, and that's why we cover it first before we move on to talk about muscular system, is providing these attachment points, for example, for muscles, so we can create these movements. Other thing that I think is very worthwhile to note about the role of the skeletal system is how it provides us protection for many vital organs. So for example, the brain is housed within the cranial cavity, the spinal cord is housed within the vertebral column. There's a nice casing if you wish for it. We'll see many vital organs like the heart and the lungs protected by our rib cage. And we're also going to see that pelvis protects some important structures there. So not only does bone give us that scaffolding, that support for other structures, it also provides us protective casing for some of the most vulnerable and vital organs. We've already touched upon the next one quickly, but I want to talk about that briefly as we are kind of thinking ahead what's going to come up in future chapters. We're going to be talking about muscles, and I wanted us to go through the bones first for the reason that muscles always attach to bones. And as muscles attach to bones, they typically cross over joints, are articulations, and as they tighten, they cause a change in that joint. So really, without skeletal system for muscles to attach, we would not be able to create movements in our body. So that's another important point to notice about the important role of the skeletal system. So we're starting to see that no system really exists on its own. Every system has overlap, even though in our model of teaching you guys, we go through them one by one. Another couple, this comes up in two different spots, is that skeletal system is important as a storage location for a lot of materials. For example, calcium, phosphorus, things like that are being stored at the bones. So we can store things and we can release things as needed. And we'll see this again when we talk about how bone is very much of a living tissue, how bone is constantly being broken down and rebuilt. So we're releasing these materials for the skeletal system to use them as needed. The calcium is the one that I've highlighted here as an example of what bones store. In addition, bone and especially bone marrow is really important for the process of hematopoiesis, which basically means formation of the blood cells in general. We'll see red blood cells, we'll see white blood cells, we'll even see platelet formation. All of those, especially the long bones of the body, contain a bone marrow, and that's going to be really important for us as a site where the blood cells are being formed. This is why in some patients where we have issues with the production of the blood cells, we might do things like bone marrow transplant to introduce those stem cells that then give rise to the blood cells that are produced within the body. So important role of the bones as well to notice. This is kind of looping back to what we've already seen before, bones as a storage site for fat cells and fat mass, we'll see especially the yellow bone marrow, particularly important as a storage place for triglycerides. So again, a lot to notice there. And let's finish this review of the functions of the bones by recognizing that bone skeletal system plays important role in also regulation of the endocrine system. So I have a nice example of there showing this kind of a loop-like path. So hormones also rely on the bones and contributions of the bones. Now let's have a look at a couple of ways to classify bones, and we're going to start with the way of classifying them as either belonging to axial skeleton or appendicular skeleton. So this is really a classification that's based on the location of the bones. So axial skeleton is made of skull, vertebral column, and rib cage. So any bone that falls within those areas would be considered as an axial skeleton bone. Axial skeleton really forms the long axis of the body. We'll see that a lot of vital organs are being enclosed within the bones of the axial skeleton as well. So if you have a good imagination, you can almost see it as a cylindrical structure. In addition to that, we have appendicular skeleton. So this really contains your upper and lower limbs and the attachment points of those bones that attach them to the upper and lower limb, attach them to the axial skeleton. So pay attention especially to these transition zones. We'll see that scapula, so our shoulder blade bone, and our clavicle, so our collarbone, are actually part of the appendicular skeleton. And similarly, notice that the hip bones are part of the appendicular skeleton as well. So those transition points are often the ones that students get confused or might have harder time. So I really encourage you to check those out. We can classify bones in addition to this by their shape. So long bones are bones that are very characteristic of being longer than wider. So we'll see especially the bones of the upper and lower limbs, humerus, ulna, radius, femur, tibia, fibula, as particularly good examples of those bones that would fall into the category of long bones. Short bones instead have very similar length and width. When we compare those, I think that carpal bones, your wrist bones, your ankle bones would be very good examples of those. The third group is going to be our flat bones. Our flat bones are characterized by the flatness of the bone. So we'll see, for example, this bones that form the skull, your sternum, so your chest bone would be particularly good ones. Notice on those examples how flat bones don't have to be completely flat. They're just flat, but they can still be curved, like in the case of the bones that form the skull. And finally, we have a fourth group or fourth classification, which is our irregular bones. Irregular bones are really kind of a catch-all group for bones that don't fall into other groups that we're seeing here, especially vertebral column, vertebrae stand out to me there. But remember that this classification is not perfect, and sometimes there can be some debate of what bones fall in within which category. And we do have fairly good standards that have developed in our practices in the field. But this is a common classification method, so I wanted to make sure that you are exposed to that. Now let's have a look of another way of classifying bone tissue especially, and we'll see this in most bones. We'll see that we have compact bone and we have spongy bone. So compact bone is really solid bone, and we'll often see this on the surfaces of the bones, forming very smooth surfaces, but also bone mass that's very, very compact, very solid type of a bone. On some bones, we'll see at the center of the bone a bone mass that's described as being spongy. This is more of a honeycomb-like structure inside the bones. The purpose of this is to reduce a little bit of the weight of the bones. If you think of birds, for example, one of the reasons why birds are able to fly is that their skeleton is so light, and how we do that is that we have hollow bones. So similarly, by reducing some of the weight of the skeleton, weight of the bones, by making some of that internal bone structure into spongy bone, we're able to make the stressors, for example, for the muscles of the neck to keep the head up far lesser. So I hope that that's helpful. I hope that that helps you to kind of highlight the differences between compact and spongy bone. Within the spongy bone, we often see a great amount of bone formation, breaking it apart, rebuilding it in response to those stress lines that are formed when the bone is exposed to use, exposed to physical stress, and it's able to strengthen in response to that by rearranging. Let's have a look of a long bone and highlight few parts of an individual long bone. So long bones are often divided into epiphyses and diaphyses. So epiphyses refers to the ends of the bone. So we would have a proximal epiphysis and distal epiphysis for most long bones. These are the ends of the bones. And then the majority of the bone's length is the middle portion, which is known as our diaphysis. We can see on this picture a bunch of other structures. We can see an articular cartilage at the bone's end. So cartilage making sure that bone doesn't rub against bone, but we have a rather smooth surface for the bones to slide past each other's at joint. We see some compact bone and spongy bone. Compact bone, especially on the outer portions of the long bones, the middle portions more spongy. We'll see an epiphyseal line, which is really the remnant from the growth plate that contributed the lengthwise growth of the long bone. And I think that rest of the structures we can see in the following picture where we're zooming in. So we'll see that we have bone cavities at the center of long bones. There we often find things like bone marrow. I also wanted to highlight how bones are surrounded by a connective tissue layer known as periosteum. Remember that bones are very much living structures, so there's a rich supply of blood providing oxygen, providing nutrients, providing energy, removing waste products to the bone tissue so that we can constantly keep that bone tissue alive and turn over there so that it can adjust to the needs of the body. So a couple of things to notice there in terms of that. Uh, these bone markings that I'm showing on the next few slides, I think are things that are going to become much more familiar to you as we review the skeleton bone by bone. And in addition to for you to know just the bones, you need to know special markings of each bone. So we'll get to use this language a little bit more at that time, but I'm already showcasing it quickly. So we'll see various different kinds of projections. Often when there's a bump on the bone, especially when it comes out, that's an attachment point, either attachment point for a muscle or a ligament. So the pull onto the muscle from this attachment point causes the, or pull on the bone from these attachment points causes the bone to often form a little bump. And we use these as landmarks when we identify from the skeleton where different muscles, for example, join into them. So lots of terminology there that might be handy, that might be useful for us. Similarly, in addition to projections, we'll see depressions, we'll see many different openings within the bones. These could be, for example, for passages of blood vessels or nerves that pass along or through structures. So bunch of structures. We'll also label certain areas of bones as well for our shared language and shared understanding. But like I said, these bone markings, we'll get to talk about them in a great detail a little later on this course. What I want to do next, I want to mention the types of bone cells that we see. And these types of bone cells are particularly important for us because, as I said, bone goes through the constant process of new bone being formed as old bone is being broken down. So let's have a look at three different types of bone cells that we'll see. And these are known as our osteoblasts, osteocytes, and osteoclasts. Osteoblasts are the bone cells that are responsible for producing new bone. And how they produce this new bone often is interesting, that they produce the new bone around themselves, so in layers. So they basically surround themselves with the new bone that they are laying out. I often do an analog of this to my students as if you were mopping the floor and you were mopping in a very uncoordinated manner, that you were just mopping all around you, you might find yourself trapped in the middle of newly mopped floor, and then you're like, what do I do now? And this is exactly what happens to our osteoblasts. So as osteoblasts lay out that new bone material around themselves, they'll eventually find themselves trapped inside that bone tissue, and they now become osteocytes. Osteocytes are mature adult bones. These mature adult bone cells are able to still communicate with other cells by having these long arching arms, if you wish, which they use to reach out to other parts, but they are trapped inside that newly laid out bone in the middle of it. So osteoblasts mature into osteocytes. But of course, there's also some bone being needing to be broken down if we're laying out new. So osteoclasts are the bone cell types that are responsible for breaking down old bone. And osteoclasts constantly do that, and as they do it, they're releasing the materials for the skeletal system to reuse, so that that material can be reused, made into a new bone by osteoblasts. So there's this constant interplay of osteoblast, osteocytes, and osteoclasts, where some old bone is being broken down by osteoclast. It's the materials from that are being used by osteoblasts to lay out new bone, and then we're left with osteocytes that are the mature adult bones trapped into the bone from the osteoblast converting into osteocytes. So an important interplay of these three different bone cell types. Here I have a little bit of microscopy of the bone tissue. I'll let you study that much more independently from our lecture material, but you'll notice that we have these central canals, Haversian systems. Osteon is a single rounded structure around the Haversian channel, around the central channel, where we have seen that bone having been laid out. As that bone is being laid out, we're forming these lamellae, these kind of rounded structures around to that. We'll also see various locations where these bone cells are reaching out to other bone cells on multiple planes, as we see also on this picture, that not all of them are to the same direction. Remember again the rich nerve, blood vessel, and lymphatic vessel supply to the bones. That's worthwhile to highlight as well, because remember, bone is very much of a living tissue. And that's really what I'm trying to highlight here on this slide, where I show at the top left corner this interplay with our bone cells, our O cells, how we are constantly breaking down old bone and laying out new bone. And that's really how our skeletal system responds to the changes. So let's say, for example, you start to exercise a lot, and as you're running, your bones are under physical stress. That causes those bones to rearrange, especially that spongy bone inside, so that we become more resistant for that physical stress. We're able to handle it, so we're rearranging that structure there. I also wanted to mention from the formation of the bony skeleton, two types of ossification. And again, these are endochondral and intermembranous ossification, and I'll let you study more about those for the interest of time in your own learning material. Finally, I have a few words about different types of fractures. So fracture is a break in the line of continuity of the bone. There's many different types of fractures. Sometimes fracture results in displaced bone endings, so they're no longer aligned. So in order to treat these kind of fractures, we need to first align them and then cast them so that they stay nicely where they should then heal. We also have non-displaced fractures, where the both bone ends are nicely located, still maintaining that structure, maintaining that line of continuity. Fractures of the bones can be complete or incomplete as well. So complete fracture is all the way true, whereas incomplete fracture would be only partially broken bone. So on the other side, it's broken, on the other side, not fully. And then we can also talk about fractures that come through the skin. So these are open fractures where the skin is penetrated. We can actually see that bone poking out. And we have closed fractures where the skin is not penetrated, but the bone is still broken, but it doesn't show up on the external part of the body. It doesn't come through the skin. Obviously, there's many other classification types of the bones fractures as well. You'll again get to read a little bit more of these on your own. I want to highlight the green streak fractures. That's like when you take a new branch of a tree and you try to bend it. It might crack on one side, but the other side still remains together. So like a green stick, very much. And we see these green streak fractures, especially on our younger patients, where the fracture is not complete all the way through. I wanted to finish off by mentioning a little bit about clinical relevance. One condition that's particularly interesting for us is osteoporosis. Osteoporosis is when the bone density is compromised. So this is something that affects especially our older population and especially population of females after menopause. There's many reasons for that. We could see, for example, is the diet containing enough calcium and protein? We're seeing is the bone being put enough under that stress so that it gets renewed and strengthened? Are we seeing that hormone levels are accurate? And this is where hormone replacement therapy would, for example, step in postmenopausal women. Really staying active, living healthy life is key in many ways, and that applies very much to the osteoporosis as well. So I already kind of touched upon this a little bit, making sure that there is sufficient supply of calcium, vitamin D, we're doing some exercising. And like I said, in terms of especially postmenopausal women, hormone replacement therapy might be something to consider. That doesn't really reverse the osteoporosis, the bone loss that has had taken place, but it might slow down its progressing. So lots of things to consider there when it comes to the clinical application as well. And that really brings us to the end of everything I had planned to cover today. On our earlier live online session this week, I did spend a little bit of time looking at some homework examples as well. So if that's something that you might find useful, you might refer back to that live online session recording. But I think it's a very similar to what we've seen in the past in terms of the structure. And that really brings me to the end of everything I wanted to share today. As always, please remember, even though this is an asynchronous course, that doesn't mean that you're on your own. We have places for all the students to interact together, and I am here to help you. So again, utilize those discussion forums, utilize chances to interact with each other, utilize chances to interact with me. I do try to offer these live online sessions. I try to offer online office hours. I am very available. If you reach out to me, I'll find a time and date that works for both of us to get together and be able to solve any questions you have, troubleshoot, or just explore more complex topics together. So again, remember all those resources. Discussion forums are not just for you to answer to questions, even though I really appreciate that and I appreciate those conversations and organic observations. They are places also for you to ask questions at, as places to share realizations, insights that has come to your material. So I appreciate you very much for being part of this class and all your great work. That really is the secret to our online courses, that you keep collecting those points throughout the semester and you're off to a great success. As always, thank you for being part of this course, and I look forward to seeing you on those various spaces that we have for our courses, and let's make it another great week. Thank you so much for being part of this course. I know.